Hello and welcome to Saurav's classes. Today we are discussing the CMI MS Data Science paper. This is the first question, which says there are 6 children A, B, C, D, E and F who are sitting around a circular table at a birthday party. Each of them may be seated or standing. So this is very important. So they are seated in order. So 1, 2, 3, 4, 5, 6. So let's take it as A, B, C, D, E, F. Then they play a game. The game is that the birthday girl's father calls out the initials of a pair of children seated next to each other. The children whose initials are called out then change their position from sitting to standing or vice versa. That means if they are sitting, they will stand. If they are standing, they will sit. Initially, all children are seated. Which of the following announcements will result in an arrangement where A and E are standing and other 4 children are seated? So here what we have to understand is, if someone's name is called out once, then he will stand. If his name is called out twice, then he will again sit down. If his name is called out thrice, then he will stand again, and so on. So that means if the name is called odd number of times, then that person will be standing. And if the name is called even number of times, then that person will be sitting. So this is what we have to understand. Now we want A and E to be standing. That means A and E has to be odd number of times, and the rest, which are B, C, D, F, have to be even number of times, so that they will be sitting. So now let us look at the arrangement. In the first arrangement, A is called out once, twice, thrice. So A will be standing. Now let's talk about E. E is called out only once. So that means E will also be standing. Now let us look at B. B is called out once, twice. So B is even. So B will be sitting. Similarly, C is called out once, twice. So C is going to be sitting. D is called out once, twice. So D is also going to be sitting. And F is also called out once, twice. So F is also going to be sitting. So this is the arrangement which is going to make A and E standing and B, C, D, F will be sitting. So the answer is option A. We move to question number 2, which says that consider the following single variable real valued functions. Fx is given by x to the power 4 plus 1 by x cube minus 1, and gx is given by x cube minus x by x cube plus x. So we can simplify gx as x times x square minus 1 by x times x square plus 1. So that means in case of gx, we can see that there is a removable discontinuity at x equal to 0. So we can cancel it out. That means there will be a hole at x equal to 0. Now let us look at the statements. The function f has a removable discontinuity at 1. Now fx has a discontinuity at x equal to 1 because there is x cube minus 1 in the denominator, which means fx can be written as x to the power 4 plus 1 by x minus 1 into x square plus x plus 1. So x minus 1 is a discontinuity for fx, but it's not removable because there is no factor of x minus 1 in the numerator, so I cannot cancel it out. So this statement is incorrect. G has it at 0, x equal to 0, which is correct. But the first part is incorrect, so that means this statement is false. We look at the second statement. G is continuous everywhere. Now we can clearly see that G is not continuous at x equal to 0. There will be a hole at x equal to 0. So there is a hole at x equal to 0. So that means discontinuous at x equal to 0. So therefore this is also false. Now we look at number 3 or number C. As x tends to infinity, f of x also tends to infinity. Now what is f of x? F of x can be written as x to the power 4 plus 1 by x cube minus 1. Now if I divide both numerator and denominator by x to the power 4, I get 1 plus 1 by x to the power 4 divided by 1 by x minus 1 by x to the power 4. So that means when x tends to infinity, 1 by x will tend to 0. That means this will become 1 plus 0 by 0, which is infinity. So therefore statement C is true. Now we look at statement D, the range of G. Now if you look at the simplified form of G, it is x square minus 1 by x square plus 1. So if I take gx equal to y equal to x square minus 1 by x square plus 1, so I have to find the range of y. So I can write this as, this is a rational function, so we can write it as x square y plus y equals x square minus 1, or we can write x square into y minus 1 equals x square into y minus 1 plus y plus 1 equals 0. So this is the quadratic. So that means the since x is real, it's a real valued function, so that means the discriminant of this will be 0. Discriminant of this will be greater than 0. So what is the discriminant here? There is no x term, so discriminant is 0 minus 4 into y minus 1 into y plus 1. So this has to be greater than equal to 0. So that means y plus 1 times y minus 1 has to be less than equal to 0, or y has to lie between plus 1 and minus 1. So the range of y, that is the range of gx, has to be between minus 1 and plus 1. So that means the range of G is bounded is a true statement. So the first two are false and the next two are